Good morning, dear friends. I am Dr. Reginam Linas, Associate Professor and HOD of Electrical Engineering Department at Sanjay Godavat University, Kolhapur. So, last class we have learned that why we need that modeling of electrical machines. What are the importance of modeling of electrical machines? In this lecture, I am going to explain about that what are the flux component in this toroid. It is excited by this electrical supply, and how the flux will be, what is the equivalent circuit of that flux will be, of that magnetic circuits will be. So with this we can learn something about how that what is the relation between what is the similarity between that flux and current, and magnetomotive force and electromotive force, and then third one is reluctance and resistance. So let me share my white screen. I hope you can see my white screen now. Let me explain about the toroid, how the magnetic flux in the toroid. Assume we have a toroid, and toroid is nothing but inside that another one core. This core is like this, and there is a winding. This is the winding we placed there. So input supply voltage, input electrical voltage we will apply here. Then number of turns in the winding we can take it as N, and current which is flowing through this nothing but I. So according to this Fleming's right hand rule, the current is this direction, so the magnetic flux path will be like this. Magnetic flux path will move. This is the path. So here the direction of flux we can write it as core. Current which is flowing through this winding is I, and the number of turns is N. Flux linkage is flux is phi c. Now from this center there is having a inner radius of Ri and outer radius of R naught. So this is the center. This is the center O. Now mean radius we can write it as mean radius R equal to R naught plus Ri divided by 2. R naught plus Ri divided by 2. Then our aim is what is the flux in this circuit, in this toroid. So in this normally according to the Ampere's law, line integral of magnetic field intensity in the line integral is nothing but total current enclosed. We can write it as number of turns in the current. So this is the line integral. Hc is equal to Hc dot dl is equal to n into I. So this path, flux linkage will be also flowing through this path. According to this, length of the path is nothing but 2 pi r. Already we know r is nothing but r naught plus mean value Ri divided by 2. So length is nothing but 2 pi r. So we can write magnetic flux intensity, magnetic field intensity into 2 pi r is equal to number of turns in the current flowing through this. So we can write core field current magnetic field intensity is nothing but number of turns divided by 2 pi r. Number of turns divided by 2 pi r. So, but based on the relation between magnetic flux density and magnetic field intensity, so magnetic flux density of the core is nothing but permeability in the magnetic field intensity of the core. So mu is nothing but mu naught into mu r. Mu naught is nothing but permeability of this air medium. So normally we will write it as 4 pi into 10 to the power minus 7 Henry per meter. Then H is nothing, mu r is nothing but relative permeability of the core. We can write normally mu r is equal to mu c also core. So accordingly, we can have another one formula for magnetic flux density is magnetic flux density is equal to flux in the air gap. So flux in the magnetic field and divided by area of the core. So from this, I already told you our motto behind this lecture is we have to find out phi c in the closed toroid. So accordingly, we have phi c, this equation which will give phi c is nothing but area of the core into magnetic field, magnetic flux density of the core. So then we can substitute this from this equation, first equation in this second. So in this second, so we can have flux in the core is nothing but mu into Hc into mu into Hc into mu Hc into Ac, area of the core. So now we already know what is Hc in this equation. So Hc we can substitute here. So already we know Hc is nothing but Ni divided by, we can write 2 pi r is nothing but length of the core, Lc, length of the core. So Ni by Lc. So now we can substitute this in this second equation. So the second equation becomes phi c equal to mu Ni by Lc into area of the core. So we can rearrange this equation as phi c is nothing but N into I divided by Lc, length of the core, divided by mu into area of the core. Already we know length of the core divided by mu into area is called as reluctance. So accordingly, we can have phi c is nothing but Ni divided by reluctance of the core. So that we can write magnetomotive force divided by reluctance. So now we are going to see the equivalency with our electrical circuit. According to the Ohm's law, current flowing through the circuit is equal to electromagnetic force divided by EMF divided by resistance. We can write voltage divided by resistance. So from this, reluctance which will oppose the flow of flux. Similarly, resistance will oppose the flow of current. So that then similarly, that equivalency of magnetomotive force is nothing but electromotive force, EMF. So this is that with this case, we can conclude that there is a equivalency between electrical circuits and magnetic circuits. Now, let me see the same toroid. There is having one air gap. Assume this is the toroid. Assume this is the toroid. In this toroid, there is having an air gap. There is having an air gap. So now you can connect like this, and this is the toroid. Here I have given this supply. So this is the supply we are giving. This is the number of turns, current which is flowing, voltage V. Now this air gap length is nothing but LG, air gap length. So here the length of the core is LC. LC is nothing but 2 pi into mean radius. So this is the magnetic flux will flows through this direction phi. Magnetic flux for phi C. This is now we have learned. So now this flux here, the core is having the permeability of mu is equal to mu naught into mu r. At the same time, this air gap having the flux permeability of mu is equal to mu naught. Since relative permeability of mu r is equal to 1 in the air, so here mu naught into mu r. So for example, if there is the relative permeability of the core is infinite, therefore the reluctance already we know, reluctance of the core, length of the core divided by mu into area of the core. So if this mu is infinite, mu r is infinity, automatically this mu term denominator will goes to infinity, automatically reluctance of the core will be 0. If otherwise the relative permeability of the core is some other value, automatically there is having the core reluctance as well. So the same flux will passing through this air gap also. Same flux will passing through this air gap also. So now in this case, we can end up with, now assume that there is a two cases with the fringing effect and with the fringing effect and without fringing effect. Without fringing effect, we have to consider. Assume that there is a without fringing effect. First, without fringing. Assume that there is a without fringing effect. In this without fringing effect, we can come to know, we have to apply for this Gauss's law. We have to apply for this Gauss's law. What Gauss's law states? The Gauss's law states that in the closed surface, magnetic flux density in the closed surface is equal to 0. So in this closed surface, magnetic flux density in the air as well as magnetic flux density in the core, both are same. Magnetic flux density in the air and magnetic flux density in the magnetic, that means we can write like this: surface integral of magnetic flux density dot n gap into ds is equal to 0. So accordingly, how it will be 0? Assume that magnetic flux density in the air gap in the core is BC, in the area of the core is AC, plus magnetic flux in the air gap in the area of the air gap is equal to 0. If I want to make it 0, how we can make it 0? PG in the area of the core is equal to minus BC in the area of the core. So for example, without fringing, area of the air gap is same as area of the core. Then since there is no losses in the flux, therefore area of the air gap is same as area of the core. Magnitude wise, we can say area of the air gap is equal to area of the core. Area of the air gap is equal to area of the core. So in the accordingly, we can with the fringing, we can assume that flux if this magnetic flux density in the air gap is equal to magnetic flux density in the core, that means magnetic flux density in the air gap is equal to magnetic flux in the core. If you use without fringing, according to the Gauss's law, total sum of flux density in the air gap is equal to 0. Accordingly, BG is equal to BC. How this BG is equal to BC? Automatically, if the areas are same, automatically fluxes are also same. So phi G is equal to phi C. So that means same flux will be coming through this air gap as well. So if this phi G is equal to phi C, we can write this, we can write this equation by using Ampere's circular law. Ampere's law, what is that? Line integral of Hc into length of the air gap plus Hg air gap magnetic field intensity in the length of the magnetic field intensity, length of the air gap is equal to number of turns in the current flowing through this. Number of turns in the current flowing through this. So accordingly, Hg in the Hc in the Lc plus Hg in the Lg equal to N in the I. Then if we use the same calculation what we have already learned, that is Hc in the length of the core plus Hg in the length of the air gap is equal to number N into I. Then what is by using this relation between what is B magnet BC is equal to mu into Hc. So from this we can write, how we can write this equation? First equation we can write BC divided by mu into Lc plus similarly air gap flux density divided by mu into length of the air gap is equal to N into I. Already we know flux is nothing, magnetic flux density B is nothing but flux divided by area of the core, or this is for core, and magnetic flux density of the air is nothing but flux in the air gap divided by area of the air gap. So accordingly, if you substitute here, we can end up with this equation phi Lc. We can substitute here. So what we will get in this first equation becomes phi C Lc divided by mu into Ac plus phi G Lg divided by mu into area of the air gap into equal to N into I. So from this, we already know L divided by mu into area is nothing but reluctance. So therefore we can have flux component. Already we came to know flux is equal, there is no fringing, phi C equal to phi G. So that is nothing but flux phi. So this equation becomes again phi, we can take it as outside, into reluctance Lc divided by mu into area of the core plus flux is already constant, therefore length of the core divided by mu naught into area of the length of the air gap divided by mu naught into area of the air gap. So that is equal to number of turns into I. So finally we can end up with phi into reluctance of core plus reluctance of air gap is equal to N into I. So from this one can conclude that there is having two reluctance multiplied by the flux is nothing but total magnetoforce force. Accordingly, we can draw the equivalent circuit of this magnetizing circuit is this is positive negative number of turns into I, then core resistance Rc then core reluctance Rc, then air gap reluctance Rg, then total flux is phi. So this is like that if the toroid having air gap, as like the previous circuit, the total reluctance path is the series connection of air gap reluctance plus core reluctance, so that this is the equivalent circuit for the toroid with the air gap. So then let me explain in the last with the fringing effect. With the fringing effect, for example, area of the core is having, the core is nothing but depth in the width of the core. Depth in the width of the core. So we can write it as depth in the depth is you assume that d, then area width is you assumed it as a, so we can write it as a into d. So now accordingly area of the core is nothing but depth in the width. So far if there is a fringing means what? There is if this is the air gap, so the magnetic flux path will goes like this. Magnetic flux, there is having a leakage. So accordingly we can write area of the air gap is greater than area of the core. Area of the air gap is greater than area of the core. So from this we can assume it as area of the core is nothing but assumed it as depth is that we already told you. I've already told you that the area of the core is nothing but width in the depth. So maybe you can take this is width is nothing but a, then depth is nothing but b. So we can write a into b. So for with the fringing effect, I already told you area of the air gap is greater than area of the core. So we can write this area of the air gap is nothing but width plus length of the air gap plus into depth plus length of the air gap, or otherwise 1.1 times of area of the air gap. So this is the normal cases. Since there is area of the air with the fringing effect, area of the air gap is greater than area of the core. So we have to come with this assumption area of the air gap is nothing but a plus length of the air gap. Maybe in our case we have written as LG, so that A plus LG into B plus LG, that is equal to 1.1 times of area of the core. So this is the detailed explanation about magnetomotive force, magnetic effect in this toroid with the air gap, without air gap, then with the fringing effect and without fringing effect. I hope this is very much interested topic only, so that it is this will help us to know the basics knowledge behind modeling of electrical machines gradually. So I hope it is very much interesting and understandable. Wish you all the best. Thank you.